Okay, so let's check and see how you did with the remaining triangles here for question 25. This triangle in the top middle here, you can see your angle of interest is right here. The longest side, one opposite of the right angle, is here, and that's your hypotenuse. From your angle of interest, you would go straight out for the opposite, and the one that's touching it is the adjacent. Top right triangle, we know the hypotenuse is here, straight out from our angle of interest is the opposite, and the one touching is the adjacent. Same thing on the one below, just want to practice so you make sure you're on the right track. We have the hypotenuse, the longest side, from our angle of interest, straight out is the opposite, and the leftover one is the adjacent. Hypotenuse again here for the longest side, straight out, opposite, and the one touching is the adjacent. Last one here, hypotenuse, longest side, from our angle of interest, straight out, opposite side, and the one touching is the adjacent. Really important that we have these correct, then we'll be able to set up the right equations to solve for sides and angles using trig. So just a reminder, we have this acronym we talked about in class, SOHCAHTOA, just a way to help you remember what trig ratios. So the S represents the sine ratio, and the sine of some angle is equal to the opposite side over the hypotenuse. So the O and the H represent the opposite over hypotenuse. The cosine function relates the adjacent over the hypotenuse, and the tangent function relates the opposite over the adjacent. So let's check these and see if they work on the triangles below. Number 26, I want you to verify that the trigonometric functions work with the below triangles. This is kind of like the Pythagorean theorem, where we had all three sides, and we just checked to see if the equation was true. There's also a chance to make sure you know how to use your calculator for trigonometry. So for the first one here on the left-hand side, I started with the sine function, and I said the sine of the angle of interest, which is 22.62, must be equal to the opposite over the hypotenuse. So I had to label all of my sides. Opposite was 5, and the hypotenuse was 13. When I substitute those two values in, I can calculate the right-hand side on a calculator, and when I do that, I get 0.3846, and I can use my calculator as well to figure out what is the sine of 22.62, and it gave me the same value. So I can verify that for this situation here, the sine function works, holds true. And I'd like you to go through and do the same thing for the cosine function. Cosine of theta relates the adjacent and the hypotenuse. And we can substitute these in. So the cosine of our angle of interest in this case was given, and it's 22.62 degrees. Is that equal to the ratio of the adjacent divided by the hypotenuse? So adjacent is 12, hypotenuse is 13. And then you can get out your calculator and check those. And once you've done that, you can do the same thing for the tangent of theta, which is opposite over adjacent. And I'd like you to check all three trig ratios for all three triangles. It's a good chance to just get some practice in on setting up these equations. Once you've had a chance to complete those, you can move on and answer the next questions here. So describe when you would want to use the Pythagorean theorem. Give an example. Number 28 is describe when you would want to use trigonometry. Give an example. And 29, describe how trigonometry works. So go ahead and answer those questions and we'll talk more about that in class.